Now, what is the incidence matrix representation of directed graph? Okay, adjacency matrix is vertex to vertex matrix, but incidence matrix is a vertex to edge matrix. So in this case, now we take one example here. Okay, and what is the matrix? What is the format of matrix? So, if a directed graph G consists of n vertices and m edges, then the incidence matrix will be of order n by m matrix, and we define C equal to Cij, and the elements of C are either 1, -1 or 0. -1 is for in degree and out degree. 1 and -1 why we define? For in degree and out degree here. So 1 if Vi is the initial vertex. If Vi is the initial vertex, for any is Ei, then put 1. -1 if Vi is the final vertex of Ei, then put -1, and 0 if Vi is not Vi has no incidence edge Ei, then put 0. So there are 3 elements, 1, -1 and 0. The number of ones in an incidence matrix is equal to the number of edges in a graph. We will verify this after finding the incidence matrix of given graph. Now this is the example here. This is the example. You to find the incidence matrix of the given directed graph. Just to recall, when it will be 1, when it will be -1, and when it will be 0. The elements of matrix. Suppose we consider a graph here. Okay. So this is V1, V4, V2 and V3. Okay, the direction is this way. This is the direction. This is the direction. Then this. This is the graph G here. Here E1, that is E2, that is E3, that is E4, and that is E5. Okay. Just to see the concept of if we have Vi to Vj, then this is Vi's initial vertex and Vj is final vertex. If direction is from Vi to Vj, then Vi is initial vertex and Vj is final vertex. Okay, so just to see the example here. The directed graph consists of 4 vertices. The vertex set for this graph is V1, V2, V3, V4. Okay. Okay. So, and H set is E1, E2, E3, E4 and E5. Then the order of the matrix will be 4 by 5. Okay. N is 4, M is 5. So the order of matrix will be 4 by 5. Okay. Now we define a matrix here. Okay. The elements of matrix, we define a matrix M equals to row represents vertices and column represents edges. So V1, V2, V3 and V4. Here is V1. Sorry, here is E1, E2, E3, E4 and E5. Okay. Now define the matrix here. Okay. Here is, first we take the V1 here. Okay. So V1, in this structure diagram, V1 that V1 is not directing from V2, but V2 is directing from V1, and so find the E1. Okay, so E1, so for E1, V2 is initial vertex, but V1 is final vertex. So we are finding for V1, so V1, the value will be -1. Okay. Now for V2 will be, it will be +1. Why? Because V2 is, for E1, V2 is initial vertex and V1 is final vertex. So we put in first value, this is -1 and this is the 1. Okay. Now V3 and V4, the E1 is not incidence on V3 and V4, so we put 0, 0. Now for the edge E2. Okay, so E2 direction, this is a V3, this is the E3. So E3 has V2 as a initial vertex and V3 has a final vertex. So for V1, so E2 is not incidence on V1, so we put 0 here. But for V2, it is 1, this is -1 and 0. Okay, why we put V3 -1 here for E2? Because for E2, V3 is the final vertex and V2 is initial vertex. Similarly for E3 has direction from V3 to V4. From V3 to V4, तो V1 के लिए 0 होगा, V2 के लिए 0, from V3 to V4, तो V3 के लिए 1 और V4 के लिए -1. Okay, now for E4 is incidence on V4 to V2. Okay, V4 to V2. So V4 to V2. So for V4 it will be 1. For V3 is 0, and for -1 and 0. So this is 0, -1, 0, 1. Okay, now E5. So E5 is incidence on V2 to V4. That means V2 is initial vertex and V1 is the final vertex. So final vertex, so we put -1 here for V1, 0, 0, and for V4 we put 1. Okay, so this is a simple incidence matrix for directed graph here. Okay, just to see example here. Okay, just to find key, what is the direction, which one is the final vertex. If it is final vertex, put -1, and if it is initial vertex for any vertex, then put 1.